So, welcome back. So, we were discussing about welding metallurgy, and then we have also discussed about the mechanics of weld design. So, today we will start with the special welding processes, and also I will discuss with you about their basic principles, working principles, and also about their comparative performance with each other. So, these are the list of special welding processes such as submerged arc welding, laser beam welding, laser spot welding, flash welding, etc. So, let us discuss them one by one. So, we will start with submerged arc welding. So, from the name itself you can understand that here in this case the arc is submerged basically beneath the flux layer. So, that is why we call it as submerged arc welding. So, what are the benefits of submerged arc welding? That is, because it is the arc is submerged beneath the flux layer. So, in this case the weld pool, that is also having much higher protection and flux cover compared to the arc welding processes, gas welding processes that we have discussed earlier. So, because of this the defects which are prone to fusion welding such as gas absorption and also inclusion and also oxide film entrapment. So, these defects are nullified to a greater extent in case of submerged arc welding. So, in this case weld arc is shielded by a granular flux that you can see over here. So, this is the layer of the flux that is at the top of the arc which is generated, and then the flux is consisting of silica, lime, manganese oxide, calcium fluoride and other compounds. So, it is fed into the weld zone by gravity flow through a nozzle. So, so you can see understand. So, this is basically the nozzle that is responsible for feeding the flux in the weld zone. So, it is a continuous process. As the weld zone moves ahead, the flux layer precedes over it. After the flux layer is laid, it is ensured that the arc is travelled, arc is going to that new weld zone progressively along the weld length, and before that the flux layer is already laid over there. So, that the arc is never bare. The thick layer of flux covers molten metal in this case. So, here flux also acts as a thermal insulator, promoting deep penetration of heat into the workpiece. So, you can also understand from this, like for example, you can see the weld pool is touching almost the thickness of the workpiece, which is shown over here. So, like we have discussed earlier that when several times earlier, when we have a thicker object, thicker plate to weld, and we are trying to weld it by butt welding route, then we have discussed that we have to go for double V, so that we can the weld zone reaches the entire thickness of the weld. So, that problem can be easily overcome in case of submerged arc welding, because of the insulating nature of the flux layer at the top of the arc, it facilitates higher penetration within the workpiece material by the arc. So, and also the consumable electrode which is used in this case is a coil of bare round wire fed automatically through a tube. So, as we have discussed earlier that the electrode can be rod, it can also be mounted over a spool, and it can be fed like a wire, because to ensure continuous operation, because in case of rod type there may be some intermittent gap between the change of subsequent rod or electrode welding rod. That problem can be nullified in this case by using wire type electrode, and also which is also a consumable electrode. That is the source of the filler metal that is being deposited in the joint for weld joint preparation. So, here power is supplied by 3-phase or 2-phase power lines in case of submerged arc welding. This is the brief of submerged arc welding. So, let us discuss now another advanced welding technique, that is called laser beam welding. So, from the name itself you can understand that here in this case the power source for welding is a laser. So, high intensity laser. So, because of that, here in case of laser beam welding, the heat affected zone that we have also discussed earlier, I am drawing again for your ease of understanding. So, again assume that this is a the single V butt joint. So, heat affected zone is much lesser in case of, so this is so you can understand from here, this is the weld pool and heat affected zone can go up to this far. In case of, this is the weld pool melt pool boundary. So, this is the HAZ. So, the HAZ width or its dimensions can be much higher in case of conventional fusion welding processes, whereas in case of laser beam welding process, because of higher the focus and it is highly focused beam. So, that is why it causes localized heating and only the weld joint which gets affected, and a very small area beside the weld joint is experiencing that heat. So, that is why in this case the heat affected zone is also will be much lesser. So, that is why the effect of the welding process over the microstructure and properties over the parts which are getting joined is is minimum. That is why it is also it is a technique where we can get cleaner joints and also filler metal not usually added, and high power density in small area. So, often used for smaller parts, and so it is normally performed with shielding gas to prevent oxidation. So, here from you can also understand that because it is a technique with high high density laser beam which is locally heating the joint region. So, often it is enough to draw out the melt from the workpiece material itself, and there is no specific requirement of filler metal addition. Of course, there are examples of filler metal addition in case of LBW also, but that is very rare. In general, it is basically a autogenous welding where we are not adding any filler material from outside for joint preparation. Okay. So, this basically shows the schematic of the laser beam welding setup. You can see the several functional parts. So, this you can see there is a lens which is basically responsible for focusing the beam over the workpiece, and from here this is a example of a single V butt joint. You can see the beam is exactly focusing on the weld joint. So, that is why my earlier discussion on lesser size of the heat affected zone you can understand from here. And also you can see that there is not much need for a filler metal assisted welding. Because the high intensity laser beam heats up the the immediate vicinity of the joint, and it is enough to draw out the liquid melt to formation of the weld pool and subsequent weld joint in a localized manner. Okay. So, so this is the brief schematic and overview of the laser beam welding process. So, what is the working principle? So, the laser welding system consists of a power source, a flash lamp filled with xenon, lasing material, focusing lens mechanism and work table. So, the flash tube flashes it at a rate of thousands per second. As a result of multiple reflections, beam power is built up to enormous level, and the output laser beam is highly directional and strong, coherent and unichromatic with a wavelength of approx 6900 Armstrong. So, it goes through a focusing device where it is pinpointed on the workpiece and fusion takes place, and the weld is accomplished due to concentrated heat produced. So, laser beam welding process is having several advantages. What are they? Wide variety of metals can be welded. There is not much restrictions in terms of the properties of the metals that can be joined by laser beam welding technique, and also the thermal damage is minimum because it is a highly focused beam and local heating of the workpiece material. So, that is why rest of the other than the joint location, other areas of the workpiece material and the assembly experiences minimum thermal damage, and weld metal is purified, good ductility and mechanical properties can be achieved in the weld joint region and also in the adjacent region, because if you recall we have discussed earlier that in case of fusion welding it is the heat affected zone which is the weakest link in the joint assembly. Because in this case again because of focused nature of the laser beam, heat affected zone size is minimum. So, overall it gives improved mechanical properties in the weld zone and also in the base metal adjacent to it. And other advantages are the welds are vacuum tight and it is filler metal is not used, that means it is an autogenous welding. So the separate attachment for arranging the feeding the filler metal in the form of rod or in the form of wire is not needed in case of laser beam welding technique, and no effect on heat treated components has been observed in case of laser beam welding. So along with these many advantages, there are of course some limitations. So what are the limitations? That laser beam welding is limited to the thickness of 1.5 mm. Because if it is going beyond that, then maybe that autogenous welding is not enough. Because the thickness is less, that means the joint size is also lesser. So that is why you can understand from here that if it is a minimum thickness joint, then it is enough for drawing out the metal from the workpiece only. So this is the workpiece material A and B, which is getting joined by the laser welding technique. So that is why, because of minimum thickness, the requirement of the weld pool melt is also much lesser, whereas if we go on increasing the workpiece thickness, then the joint will also be much bigger, and in that case it is difficult to draw out the required weld metal from the parent workpiece itself. So in that case we need to go to the addition of filler metal. So that is why because it is mostly useful as a autogenous welding technique. So that is why it is a limitation that is kept in case of LBW of minimum workpiece thickness. And materials like magnesium cannot be welded because it is highly reactive and it can cause flash or burning at the onset of onset of impingement of the laser beam and localized heating. And so what are the applications? The applications are radio engineering and microelectronics. So where laser beam welding is generally applied. Okay. And then we will move to laser spot welding. So it is also a variant of the laser beam welding. So in this case, laser are used to produce spot welds. So you can see this is basically a spot weld that is created in the fashion of a lap weld, where this one workpiece plate is placed at the top of the other one. Say this is plate A and this is plate B. So here we are basically joining both the plates by a spot weld kept at the middle. The point is kept at the middle. So however, it offers unique advantages when compared to the conventional resistance method. We will discuss next about laser resistance spot weld also, where electrical resistance is responsible for spot weld. Rather than that, in case of laser spot welding, there is not much joint preparation. So what we do here, basically we first apply, once the laser beam is applied, it creates a hole and then that hole is basically filled by the melt, which is experiencing melting the, and again it is an autogenous welding. So the melt is drawn, weld metal is drawn from the workpiece materials itself. That means it is only the composition of the joint will be the combination of A and B. Contribution of composition comes from A and B alone and not from any other externally added filler material. So here the small clamping force is applied to ensure contact of the workpieces, and a fine focused laser beam that scans the area of the weld. Welding is performed in the keyhole mode, where the laser produces first a hole and then in that hole the molten metal puddle forms. As the beam moves, molten metal flows into the hole and solidifies, so forming a fusion type nugget. So it is a non contact process and produces no indentations. And also the the basic difficulty that we generally experience in case of fusion welding process, it is the crater, also chatter, that generally happens because of the arc hitting the workpiece. So there is a localized depression that happens near to the weld zone. So that is why it is a defect, often as a permanent defect that generally takes place in the parts which are experiencing joining. So that kind of difficulty is not there in case of laser spot welding because of its highly localized nature, and so crater formation tendency is not there like arc welding. So no electrodes are involved. So electrode wear and tear is no longer a production problem that we generally experience in case of arc welding technique, be it non-consumable electrode like tungsten inert gas welding, or it's with consumable electrode like metal inert gas welding. So, these difficulties are not there in case of laser spot welding. So, weld quality is independent of material resistance, surface resistance and electrode condition, and no water cooling is required in case of laser spot welding, and the total heat input is low. So, the heat affected zone is small. Why total heat input is low? Because again because of its localized nature. So, it is not heating much the rest of the workpiece material where the weld joint is not being made, and that is why the heat affected zone is smaller, and the microstructural and property related changes that generally happens in the heat affected zone in case of arc welding or gas welding processes is minimized in case of laser spot welding technique. So, from here you can understand its superiority, and that is why it is beneficial for getting localized precision welds. Okay. So, moving on, we will discuss about the flash welding. So, flash welding you can understand from here. So, from the schematic that is drawn over here. So, you can see this is a process used to produce butt welds between similar or dissimilar metals in solid or tubular form. So, the two pieces of metal are first secured in contact current secured in current carrying grips, and then lightly touched together, so that electric current flow resumes between the two workpiece materials of similar composition or different composition, where whom we want to basically join by flash welding route. So, an electric current may be passed through the joint to provide optional preheat, after which the pieces are withdrawn slightly, and these and then please recall that we have discussed this similar principle in case of arc welding also, where electrode is initially touched with the workpiece which is anode, and the negative electrode, that is cathode, is attached with the positive charge workpiece and then withdrawn, and then it starts the boiling of the bridges and electron starts to flow. So, in this case also, after ensuring the initial current flow and preheat of at the at the contact place where the joint is supposed to be developed, and then when it is they are suddenly separated. So, then an intense flashing arc forms across the gap, which melts the material on both the surfaces, both the faying surfaces. So, the surfaces which are going to experience joining, they are basically termed as faying surfaces, FAYING, faying surfaces. And then after the melt preparation due to the flash generated at the faying surfaces, they are pressed together and a high pressure is applied. So, you can see the clamping arrangement over here for both the workpieces, candidate workpieces where who are subjected to joint formation. They are high pressure is subjected to the both the workpieces, and because of in the order of 70 MPa that expels the liquid and oxides that forms at the faying surfaces of the both the workpieces and upset, and then basically because of that pressure plastic deformation takes place. Upsetting of the softened metal takes place at the region adjacent to the contact region between the between the contact workpieces, and that is why it promotes plastic deformation and also diffusion. And that is why atomic level bondings are developed, and in turn we get the joint developed by a flash welding technique. So, the electric current is turned off and the force is maintained until solidification is complete. So, if desired, the upset portion can also be removed by machining. So, as I told that after the melt is expelled because of the applied pressure from both the sides, so then because it is experiencing a upsetting forging technique. So, that is why there is a hump that is developed because of the plastic flow of the matter from both the workpieces. So, apart from joint, there is also a hump that is created at the adjoining region, at the joint region between the workpiece materials. So, which may be based on the requirement can be kept also, and also can be trimmed off by turning, so that we can get a smooth workpiece having a cylindrical having a circular cross section, and a cylindrical workpiece can be obtained by this way. So, this is the basic principle of flash welding, And so, going ahead we will talk about percussion welding. So, it is a similar process in which a rapid discharge of stored energy produces a brief period of arcing, and which is followed by the rapid application of force to expel the molten metal and produce the joint. So, in percussion welding the duration of the arc is on the order of 1 to 10 milliseconds. The heat is intense but highly concentrated. Only a small amount of molten metal is produced. Little or no offsetting occurs at the joint, and the heat affected zone is quite small. It is even smaller than the flash welding technique, because in this case the duration of arc is very less, maximum 10 milliseconds. So, you can understand from there. So, that is why there is not much heat which is generated. So, it is less heat, rather more pressure that is applied in case of from both the sides of the cylindrical workpieces, which is responsible for joint development in case of percussion welding. So, application is generally restricted to the butt welding of bar or tubing, where heat damage is a major concern. Okay. So, and then followed by that we will go to the offset welding. So, it is also a similar technique to the flash welding, but there is no period of arcing. So, this is entirely a solid state welding technique. That is the difference from the flash welding, which is a a mixture of both, because we are producing liquid melt or weld metal at the faying surfaces, which is not the case in case of offset welding. So, the equipment and geometries are similar, but the heating is achieved through electrical resistance, and electrical resistance heating is not enough for melt preparation, rather it heat up the workpieces, the faying surfaces, because of that it is becomes much easier for the plastic flow of matter and joint formation at the intended location. So, the parts are clamped into the machine, pressure is applied and high current is passed through the joint. So, when the aborting surfaces have been heated to suitable forging temperature, the current is stopped and the offsetting force is applied to produce coalition. So, please focus on this. So, this is basically it is heated up to the forging temperature. So, this is the difference with the flash welding and percussion welding. So, we never talk about melting or weld metal preparation at the faying surfaces in case of offset welding. So, the initial conditions of interface flatness, finish and alignment must create uniform contact if a good quality weld is to be developed by a offset welding route. Okay. So, moving on, we will go to the now electroslag welding. So, electroslag welding, from the schematic itself you can understand that it is useful for a edge joint preparation. It is of course a butt joint, that means, but it is useful for very deep joint preparation. So, it is generally in the case of naval ships and also pressure vessels, where you have a long structure which is having a significant height from the ground or from the origin of the structure. So, that in that long height it is much effective to go for electroslag welding technique, where there is a slag layer at the top of the weld metal weld melt pool that is created in the joint region. So, in this case arc is generated between a consumable electrode and workpiece, and due to this, so this is basically the consumable electrode. You can see the electrode wire feed, and that is basically a consumable electrode, which is also responsible for arcing and also responsible for weld metal production for joint development. And this is the guide tube through which the wire feed or also you can also call it as a torch, where from the the electrode wire is fed to the joint location. So, in this case melting the electrode material, liquid melt can be produced between two surfaces by adding sufficient amount of the flux. Slug will be produced. When the height of the liquid melt is increased, it is in contact with electrode. Due to short circuit, electric arc will be extinguished. By supplying high rate of current, heat generation will be continued due to resistance of the slag. So, you can see that there is a period of arcing and period of extinguishing is also involved in case of electroslag welding. However, the slag layer that is kept at the top of the melt pool is responsible for creating the contact resistance, and also it is serving as a insulating body, so that there is not much heat leakage from the weld joint, and that is why because of that there is the microstructure formed in the joint in case of electroslag welding is also much improved because of uniform cooling, because of because there is no leakage from the free surface of the weld pool. So, that is why there is no variable cooling rate, not much variable cooling rate, and associated microstructural heterogeneity, anisotropy of properties that we generally observe in case of other thick welds developed using arc welding techniques or gas welding techniques. So, those are inherently nullified in case of electroslag welding route. So, and here because it is in because of short circuiting with the liquid melt and the electrode where the period where the arc gets extinguished. So, during that period, by supplying high rate of current, heat generation is continued due to resistance of the slag. So, that is why although the arc experiences a temporary extinguishing, but still it is not it does not cause sudden cooling of the joint and associated hot cracking or defect formation. So, here welding can take place in vertically upward direction, and that is why it is very much effective for naval applications and also pressure vessel applications. So, here some of the applications of electroslag welding are listed. As I told you that it is useful for very large forging and casting parts to create a composite structure. It is used for welding large ships. I already told about the naval applications, and also it is widely used in the welding of pressure vessels, and this is the method of welding which was used for the welding of construction steel since the late 90s. Although nowadays there are improved techniques such as friction stir welding has come, and which is now being used for for a long vertical welds for a thicker structures. However, electroslag welding is the one which was used since long, and it is still having relevance for many of the applications. So, then moving on, we will discuss now the electron beam welding. So, it is quite similar with laser beam welding, only the source of energy heat source is, in spite of laser, now it is electron beam. Of course, there are other functional differences, so that we will try to discuss. So, fusion welding processes in which heat for welding is provided by a highly focused high intensity stream of electrons striking the work surface are termed as electron beam welding. So, electron beam gun operates at high voltage, that is between 10 to 150 kilovolt typically, to accelerate electrons, and beam currents are low, measured in milliamps. And the working principle, the kinetic energy of the electrons is converted into intense heat energy when the electrons are absorbed by the metal piece, the work piece. So, over a small area of the weld, it produces deep penetration weld with a depth width ratio as high as 15. So, that means from here itself you can understand that electron beam welding is also capable of producing deep narrow welds because of higher depth to width ratio. So, it is, if this depth is, say, if we mark it as d, and the width if we mark it as w. So, then d by w is equal to 15 or greater than equal to 15. So, in this case it is way ahead of laser beam welding, because please recall that we have discussed that laser beam welding there is a thickness restriction, because beyond a certain thickness the the autogenous nature of laser beam welding fails to fill the joint with the enough weld metal which is necessary for developing a strong metallurgical bonding between the faying surfaces, whereas in case of electron beam welding being much stronger as a focused collimated beam, it can weld very narrow and deep sections. So, this results in narrow almost parallel weld with very little distortion, and that is another region. So, why there is little distortion? Because of the focused nature of the electron beam like laser. So, in this case as well the heat affected zone is much smaller in size, and that causes lesser focused that causes lesser heat affected zone, and it causes, and also there is no possibility of contamination by atmospheric gases, because this process is carried out in vacuum. So, this is electron beam welding. Also we will now draw a comparison between laser beam welding and electron beam welding. So, in this case no vacuum chamber required for laser beam welding, no X-rays emitted in case of laser beam welding, and so these are the advantages in LBW. However, vacuum chamber is needed for EBW, and X-rays are emitted in case of EBW. So, that is the disadvantage compared to LBW. Laser beams can be focused and directed by optical lenses and mirrors, whereas in case of electron beam welding the equipments necessary for the generation of the electron beam is much costlier, and LBW is not capable of the deep welds and high depth to weight ratio, that also we have discussed. So, so the maximum LBW depth is around 19 mm, that is also on the higher side. It is generally restricted between 7 to 10 mm, although maximum can be 19 mm. So, whereas EBW can comfortably weld up to 50 mm deep. So, that is a major advantage of EBW over LBW technique. And other advantages of EBW is it is producing high quality welds, with minimum heat affected zone and with a much higher welding speed, and also again in this case EBW is also a autogenous technique, and also no flux or shielding gases are needed. Okay. So, so with this we are stopping for this class, and we will discuss about some other advanced welding techniques in the next class, and yeah. So, for till then thank you. So, we will join back soon.